All right. Now, in this video, we are going to talk about the slope of a line, specifically how you find or how you identify the slope of a line just by looking at a graph. All right. Uh, this is a big topic. This is our start for linear functions. It's huge. Can't describe how important it is for Algebra 1 and Algebra 2. There's a lot to it, and it's really good stuff. Now, you may have talked about slope in the past. Basically, it's a number that we use to describe how tilted a line is. All right. So this line right here has a little bit of a slope. All right. Right here, it has less slope. And here, you would say it has a lot of slope. It's really tilted. Now, in the real world, they have different words to describe the slope of a line. One of them that they use is gradient. So let's say this is a road, all right? This might have a gradient of a certain percentage. Instead of describing, instead of calling it the slope, they would describe the gradient. And if it's a higher gradient, then it would be a higher sloped road. Also for like roofs, if you were looking at a roof that's shaped, kind of imagine this one side of a roof. This would have a certain pitch. They might call it a pitch. Or let's say you're in science class and they're trying to describe the growth of a population. All right. The growth of a population in terms of time. So like right here on the x-axis, this might be 1 year. This might be 2 years, 3 years. And the up and down, the y-axis, is how much they've grown. So this example right here might have a small growth or a small rate of change. This would be a really high rate of change. They're growing really fast. All right, but what I want you to catch here is that slope is a number. Okay, slope is a fraction. And I'll talk to you here in a little bit about what exactly I mean by that. First, let's talk about whether a slope is positive or negative. Okay, it can be kind of confusing whenever they're tilted really a lot, high slope. But if you're trying to just tell if it's positive or negative, read it. You have to look at it from left to right and just ask whether it's going uphill or downhill. So this one, you can see from left to right, if you're going from the left side to the right side, it's actually going uphill. So we would say this has positive slope. This would be positive as well. This would be positive. This would be positive. Way down here, this would be positive. And if you wanted to mention negative slope, it's just the opposite. From left to right, it would be going downhill. Okay. So as this thing goes downhill, it has negative slope. These all right here have negative slope. From left to right, it's going downhill. So you see here it says rise and run. That's the most popular way in math is that they describe the slope. They talk about, from the red dots, what's the rise? What's the up and down between the red dots? And what's the run? What's the distance across? Or the left and right distance between the dots. And that's what I'm going to use whenever I talk about the slope of a line. So we're going to do an example here. So we've got 3 dots, A, B, AC, and BC. We're going to pretend that we are drawing a line between them. All right, so that would be line AC. This would be line AB. And we're going to calculate the slope of the line for each of these. So remember how I said that the slope of a line, slope, is a fraction, okay? The top number of the fraction, they always call the rise. The bottom number, they call the run. The way I think of it is, you have 2 points. We'll do A and B, actually. And what we have to do is we have to calculate or count. We have to count the up and down distance from A to B. So we need to count the up and down distance, and that's going to be the top number of our fraction. So from A to B, it's just 1 unit. Each of these little segments here is 1 unit. So it's 1 unit up and down. That's the top number of our fraction. And then the bottom number is going to be how far apart they are left and right. So here it's just 1, 2. So that's our bottom number. And notice from A to B, does it have positive or negative slope? It has negative slope. So we would just attach a negative sign out there. And that would be the slope of the line that connects points A and B. Okay, let's do A and C. Okay, let's change the color here. Yeah, so from A to C, it does have positive slope. We need to count how far they are up and down from each other. So 1, 2, 3. So it's 3 units up and down. And then we need to count how far apart they are left and right from each other. That's the run, the bottom number. 1, 2, 3, 4. So 3/4 would be the slope of the line between A and C. Okay, 3/4. Let me back that off a little. Yeah, we'll call that AC. Then the last one here, let's look at BC. We'll do purple. Purple will stand out enough. So the rise, we need to count how far apart they are up and down from each other. 1, 2, 3, 4. So 4 is the top number of our fraction. And then the run, how far apart left and right. So from where we left off there, 1, 2. So the slope between B and C would be 4/2, or you can just simplify that. That'd be 2/1, or you could just call it 2. And that, and it's positive slope. Sorry, yeah, notice that. It is positive slope between there because it's going uphill. I think that'll do it for this one.